Welcome everyone to today's webinar. We're going to be looking at doing DevOps in the cloud, a practical approach. Little bit of housekeeping today. The webinar is scheduled to last 1 hour. We'll have a Q&A session later on. The webinar will be recorded and we'll send the recording out later on. Questions can be submitted via GoToWebinar questions panel anytime. We'll get to them after after our content is done. So a little bit about me. My name is Yogi Aradhye. I'm a principal consultant at HeadSpring. I've been doing distributed system DevOps. Been doing a little bit of OSS development on contract testing. I've spoken at international conferences and local conferences in the United States. I've been blogger at HeadSpring blog, as well as my personal blog, which is my last name, Aradhye.com. And my co-presenter today is Patrick McVeety-Mill.
Hey, yeah, I'm Patrick McVeety-Mill. I'm also a principal consultant at HeadSpring. Over the past couple of years, I've really taken a focus on DevOps, things like automation, and also on migrating legacy apps to the cloud. You may recognize my voice as the host of HeadSpring's podcast, OK Human, which Yogi was my first guest on. So good to be back with you, Yogi.
It's always fun to talk to Patrick. All right, let's get into this. Before anything else, let's level set. Like, why do we exist as engineers, and what are we trying to do? When we're talking about software engineering, we are trying to deliver business goals. We are trying to deliver software as quickly as possible. We want to make sure that we deliver it correctly. We're not just tossing something over the fence and saying, my job's done. We want to do it correctly. We want to deliver a quality product. We're just not doing it because, to show off like how awesome my skills are or whatever. Even the best OSS projects, right? They last longer because they're trying to solve a real business problem instead of just somebody's experiment, which happens a lot and there's nothing wrong with it. But if there's a problem that a lot of people are having, and then the particular OSS project is solving that problem, like AutoMapper, they tend to last longer. There's a lot of traction behind that. So that's why we exist. Today we're going to look at how DevOps helps in achieving these goals.
Yeah, so with those goals of delivering value in mind, we'll be looking at sort of what led us to DevOps and why DevOps, why we should care about it. Some practical approaches for success, how to use DevOps without going overboard on it in a pragmatic way. And we'll end with a showcase of cloud tools. That'll be a good starting point for getting into this.
Sounds good. So why should you care? We looked at what we're going to look at today, why DevOps matters and why it mattered to me. So I was on a project that was basically, we were converting a monolith to microservices project. It had 140 odd CS projects in one solution. 50 plus dev teams are working on this one giant monolithic solution. And you could see like a lot of times Visual Studio would just crash, try to open this thing. You couldn't turn on things like ReSharper or anything like that. And then the development process itself was time consuming. And then once you develop your solution to the problem, you deploy this thing as like a big ceremony. There will be carnival, op deployment. And then in that as well, something somewhere would go wrong and the whole thing will be rolled back. So even if you didn't cause anything wrong in your particular team's area, something else somewhere would go wrong and the whole build would roll back. And this was happening to almost 60% of the build. It was really a painful time for the devs, and all these people across the world were really frustrated with this experience because when they're trying to solve a problem, there was weeks worth of lead time. The business comes up with, okay, this is what we need to do. Even if you're just changing a couple lines of code here and there, or building a full-fledged feature, it would take a lot of time to get that actually in production. And then, of course, frequent rollbacks of the application, everything, a lot of waste of time. And it was really frustrating experience, and that caused a lot of low morale in engineers. There's a lot of turnover. People are often frustrated, and then there's no fun in that kind of environment when everybody's frustrated and kind of really stressed out about all these things, because they know even if they know the solution and they have the solution ready, it can't be in front of the users as quickly as they want. So while I was working on this project, it kind of like this quote resonated me very well, and I read this in Sam Newman's book, Building Microservices. What he's really saying is that we cannot prevent all the failures from happening. That's just impossible goal. We should instead what we should concentrate on how we can build some robust pipelines so that we can respond to these failures as they're happening in production, and then fix those things as quickly as possible. This doesn't mean deploy some trashy code in production. This doesn't mean, all right, let's just test in production, or remove all of your tests, unit tests and whatnot. That doesn't mean that. It just means that we're building some lanes that are going to be really robust, so that our code is going to be deployed really quickly, and it will be in front of the users as quickly as possible. So it really resonated with me. At the same time, I came across this State of the DevOps report, and a lot of great companies here, led by Google, came up with this report. 30,000 plus people responded over 6 years, and they compiled this information that people are responding to and seeing like what's happening from their DevOps world. And then you can still take this survey, by the way, and see where your organization stands. You can go find out with the Google DevOps report, and then you should be able to get the report as well as the survey and see where you're at from DevOps standpoint. So what that report really said was that elite performers are doing something different than rest of the people. They are deploying a lot more faster. The time to respond to things that they're as the problems are coming up, the lead times are lower, and they're deploying as frequently as possible. So if you think about it, like your flip card that you used to have back in the day, the cartoon, and then you flip through really quickly. So even if the things were like, on a different page, the picture was on a different page, it gave you the illusion of one smooth thing that's what you're seeing. So it doesn't mean that these problems don't exist in the elite performing organizations, but they've fixed these problems so quickly that before the users realize that the problems are already taken care of, and it gives the illusion of stability, even if the things are not stable at times, because we just know that things are not perfectly happy all the time. Everything's not great all the time, especially when you're looking at the scale, looking at applications like Amazon or whatever like that. There's a lot of traffic on them, so it's not that they don't have problems, but they're doing something different to solve these problems, which is the frequent deployment. And that's what that really report talked about. So just to recap that report, the struggling organizations, which I had the first-hand experience with in my monolith to microservices project, there was weeks worth of lead time, versus the successful organizations were really deploying the applications as quickly as possible. And they were more stable, more productive, high morale, things like that. So I could find direct correlationship between the DevOps report, that things were happening right in the great organizations, successful organizations, versus the struggles that I had seen on the project that I was on. So, so companies like Amazon deploy thousands of times a day. So this is a lofty goal. We're not saying that you start with that goal. If you do, power to you. Nothing stopping you from that. However, how do we at least reduce that to, let's say, if you had monthly deployment, from monthly to biweekly maybe, and from if you had biweekly to weekly, or 2-3 times a week, and if you had 2-3 times a week, how can you reduce that from once or twice a day? Things like that you should be able to think about, and that's what this really was telling us. This report kind of gave the idea about what can we do to really push the envelope on pushing our code as quickly as possible to production, so that we can kind of get close to what the successful organizations are doing. So DevOps helps you deliver value to your customers. What we are really talking about here is, the successful organizations example, how they create even if they are having problems, how they are creating illusion of stability and things like that. So what can we do? How can we build these fast lanes and get the product in front of our customers as quickly as possible? So we understand the reasons behind why DevOps, the Google's survey and the report that they compile, along with others, are telling us that these are the things that are happening in the industry. But what exactly is DevOps?
So if we look at what Google's definition of DevOps, since they put together this report, what's the frame that they're using? Their formal definition is DevOps is an organizational and cultural movement to increase software velocity, improve service reliability, and build shared ownership among software developers and stakeholders. So this has a real emphasis on not just the tooling of it, but also the cultural and organization-wide change, sharing ownership, that it's not just on your devs or your SREs to be doing DevOps. At Headspring, we have a similar holistic approach that covers a lot of different facets, from the kind of tried and true things like continuous delivery and trunk-based development using your source control smart, automation, measuring, logging, but then also things like architecture, like how can the way our apps are structured empower us to focus on important problems using events and good loose coupling and domain-driven design. Also, the way that we work, the process that we take for building these apps, taking small work slices, thinking again about automation, and then also allowing for some experimentation and room to grow and improve. And ultimately, that all builds towards a culture of success where we're collaborating between our teams. Everybody's invested in that shared ownership. We're looking at building leaders within that, and just everybody's working together to make this. And when we look at the monolith example, and that was a culture of frustration and slowness, that instead a true DevOps culture is one of wins and success and growth. So our formal definition, if you want to hit it, Yogi, thank you, is very similar to Google's. It's has elements about tools, but also people, and we tack on an extra emphasis at the end about it changing things specifically with and in the cloud, because we think that cloud is a essential part of the ecosystem of technology, that it allows us to do DevOps in such a more impactful way and implement these with a lot more ease, because a lot of the elements of DevOps are complicated, and we can get a lot more from them with less work if we use the cloud. And when we think about why is that, we go back to this analogy you may have heard of, treating your infrastructure and your technology as pets versus a herd of cattle. As a vegetarian, we're going to do houseplants in a cornfield instead, but the meaning is the same, where your houseplant is precious and requires some immediate care. And then also if you mess up and it dies, it's gone. That was it. That was your one plant in that pot, and it's over. So that's like if you've got an app that's tightly coupled, your infrastructure's on premise and you're setting it up manually. That's your house plant. With a cornfield, you're running. It's huge. It's automated. You're running, you're planting it all at once, you're growing it all. And if there's a few bad stalks in it, it's not going to spoil the rest of your yield. You're still going to be okay. And that's when, in technology, that's when we're containerizing our apps. We're using platform as a service, and we're automating the setup and teardown. We're a bit more fault tolerant. So taking these, if we want a cornfield, we find that it's much easier to implement in the cloud using cloud services or cloud hosting and tools. And also there are a lot of other pillars of sort of DevOps culture and thinking that the cloud can provide us.
Right. So again, the infrastructure, the entry point for these things, when you do it in cloud, it's a lot more straightforward as compared to something like on-prem. I recently had an experience working with Azure Logic Apps, and when we were doing that, we weren't exactly sure that that approach was going to work for us. But since it was readily available, I could do quick experiment and find out that in a time box that thing saying, okay, in the next couple of hours, if my experiment works, then we're going to move forward with this. Otherwise, we're not. And it worked, luckily. But then if it didn't, it wasn't going to cost me too much to just say, okay, it's not going to work. I need to go somewhere else and find out what's going to work for me. Previously, what we'd have to do was build something, the flow that we had, using some kind of a Windows workflow foundation, deploy it on a VM, wait for people to deploy that thing and see how it works and things like that. So it would have taken me days to figure out whether my experiment was good or not. Instead, on Logic Apps, I was able to figure that out in like an hour or two, and that was mostly my development time and things like that, instead of like any lead time that was just getting introduced by the red tape or the processes and things like that. So that's really important from a DevOps standpoint, that, hey, I need that quick feedback. I need to know if something's going to work for me or not. And that's what cloud enables, and that kind of leads to low costs and then avoiding like big mistakes going forward. Like, hey, I can just do quick experiment on small things. If it works, then I can expand it. I can scale that further. You can also scale it for your needs. Things like that, built-in tooling, a lot of good stuff that's out there. I don't have to reinvent the wheel. I can really concentrate on solving my business problems. So a lot of these things are pretty much out there. Like a lot of you probably know about these things. You're on cloud, but just wanted to reiterate like why we think that DevOps must be done. Like why cloud is a crucial feature of DevOps. So with that, yeah, a lot of these practices and things like that we saw from Headspring standpoint, they're critical, but it could be time consuming, and there's always room for improvement. But there are trade-offs too. So when we looked at what we do from Headspring standpoint, that we have continuous delivery, measurement, architecture, processes, and things like that are involved in all these things, they land on a spectrum where certain things with the advancements of technology and tools, you could do CI/CD really quickly these days. There are a lot of options out there, a lot of great options, which we'll see later on as well, where you can do. You can measure your things really quickly as well. You can build that infrastructure if you need to. Depends on what your application does. Things like that, where once you start moving a little bit towards right, things like culture would take a long time to change, definitely longer than fixing your build process, for example. So what you can look at these things from the spectrum standpoint, like, that there are certain things that are going to take longer, they're going to be slower, but that doesn't mean you shouldn't be doing these smaller, faster things as quickly as possible, because these things are all interconnected, and that's why they're part of DevOps. So from Sprint Zero standpoint, I'll let Patrick continue here.
Yeah, when we're looking at those small changes that we can implement quickly, we think of those as our Sprint Zero considerations, because we'll do them right away and we'll start seeing value, and it doesn't take a lot of time to get them set up. So these are also where you start if you want to introduce a more of a DevOps practice to your application as you've got it now. Things like Yogi mentioned, setting up your CI/CD pipeline, getting more logging in for observability. Starting to think about your architecture and maybe simplify it in small ways. Doing business analysis to break up your work into smaller slices. Looking at things like security, and what doing these changes can reduce the cost of the later changes that you might make and introduce from a difficulty standpoint, or their cost, or just the larger scope. And a lot of it has to do with being prepared too. Is you want these in place so that you're ready when as you go.
Right, and then the observability and security, they're like the water bottle that you take on a hike, right? Like you don't really realize sitting in your AC living room that, hey, you're gonna need this thing when you go on a hike, but when you do, you really need it, and you can't really go without that. Twitter found that out, recently, that, hey, the hack that happened yesterday, all the celebrities got hacked, and the Bitcoin stuff went on their accounts and things like that. So at that point, they couldn't have said, oh, I wish if we had some good security tools, or I wish if we had some good observability tools in place. No, that thing begins really early in the process. You want to have those things right away, because you know you're going to need those, and that's what we include into our Sprint Zero considerations, because they're really crucial from making sure that your pipelines are robust, and going back to Sam's quote, that we are pushing the code as quickly as possible and building those fast lanes. So you want to you want all of these things ideally, but you have to start somewhere.
Yeah, when we look at those, the starting points, they are related to some of those larger and slower changes that we have. So if you want deep observability across all of your apps, that's going to take a while if you really want good, strong diagnostics and reporting. But you can start having more descriptive and more plentiful logs right now. Totally replatforming your app, moving to the cloud, things like that, that's a large effort. But if you start making small application level changes now, eventually you'll have moved off of the old libraries, you'll be able to support cloud infrastructure. Doing an org-wide process overhaul, that's really hard. But if you start introducing some asynchronous teamwork practices, doing a little bit more online meetings, maybe you already are because of COVID, that will grow towards a larger process change. Ultimately, all of these small behaviors deploying more frequently, you're going to see the business impact to your customers faster. It builds a culture. You can't just dive into a new culture, but if you start adjusting your behavior bit by bit, incrementally, you'll eventually land on having changed your culture as a whole.
Right. I don't think anybody will have any change if we say, oh, tomorrow we're going to change our culture. Let's change this everything. Like we want to start that process in piecemeal. We have things, and that's what really Patrick's getting at.
So if we're looking at what are those small changes, how do I start changing my behavior? The first one we're going to talk about is measurement. So when you think about observability and logging and tracking, you really just want to leverage your platform. That's going to be the fastest way to start getting that value. So think about having configurable structured logging that you can turn on and off, and it's telling you everything that you need to know when you're looking at it. You want good request tracking and diagnostics. You want, if your system's already distributed, that's good for you. And you want traceability though through that. So when you have a problem, right, you're prepared to troubleshoot it. You can go, you've been measuring, you know where to look. Jimmy Bogard with Headspring, our own, he's been working on end service bus extensions for diagnostics that are really cool for just tracking metrics through all of those different buses, and the through line from a business action. How does that trace between each of the microservices that it might be touching? Some other examples, and what's great about these tools is that you probably, if you're in the cloud, you've already got them. If you're on AWS, there's AWS CloudWatch, which is a really powerful tool that lets you build dashboards and make all these charts, and it's just build reports out of it. A lot of piecemeal math building, math building. Lots of math in that one. Azure Monitor is very similar. You can do log rollups. You've got containers tracking. If you're on Kubernetes, you wire all these in and see what containers are up or down or restarting. Code diagnostics. There's some really cool tools if you hit it, Yogi, that I've gotten a lot of value from Azure in application insights and log analytics, where if you're writing a .NET app, you can see like stack traces that go with the log failure. You can see the dependencies, see what the actual like breakdown of your SQL queries are. And that's just like, that's built in. You click a single button and you instantly get all of these metrics and diagnostics. So these are built into the platforms that you're using. There are also a lot of good third-party options that you can install if you're still on-prem, or if you want some extra or specific tools like the Elk Stack or New Relic or Zipkin. Or I know Yogi's a big fan of Honeycomb.
Yeah, definitely, because the best part about Honeycomb, you can set the service level objective that you may have for your services. Like in this case, the picture here shows the latency per event. An event in this case really means like what happens when the request is originated on the user's browser, and then whatever the thing has to happen to serve that request. That's what they mean by event, and how long it takes for that event. And then you can set yourself some kind of a goal, saying, oh, my goal is my average request should not take, let's say, more than 70 milliseconds, spanned over 2 hours of data or whatever. That's your goal. Then in this case, they're doing it 30 days. So you can set yourself a goal like that and measure against that and see where you're falling, what your average request times are, and things like that. So what that tells you is like, see how it's giving you insight based on, okay, this is what my goal is, but this is what the reality is, and what I need to do to meet that goal. Do I have an unreasonable goal? Is my goal really lofty, like deploy application really quickly as possible, or we were talking about the example of Amazon where we said, oh, we wanted to deploy application 30,000 times a day. That could be lofty. So similar to that, are you saying that your SLO is lofty like that, or your application is performing in really slow way? So you can really think about these things. It gives you really data-driven way of doing the analysis. And the other favorite part of mine of this tool is the error budgets. So there's no application with zero errors. That's just not a thing. And if a production application that's used by real people has zero errors, and you think that's a thing, then you're just not looking hard enough, or you may not have the tools to look into those things, or they're not getting surfaced correctly. So that thing exists. So you can't really have zero errors. You can't eliminate everything, because at some point the returns are diminishing, trying to reduce these number of errors. The amount of infrastructure that you have to throw at these things, in amount of man hours that you have to throw at these things, the developer hours at this thing, it may not give you just ROI at that point. So achieving that zero error is an unrealistic goal. But then what is the realistic goal? And that's what you can set with the error budget, saying, okay, over a particular period of time, I should not have more than, let's say, 10 errors, or whatever the number that you think is reasonable for your application. And then if you consistently, let's say you did a deployment, and then if you consistently see that error budget is getting broken or something like that, you're going over that, then you know something went wrong, something's out of the ordinary, I need to go do these things. Or if somebody needs to be woken up at midnight or early hours in the morning, you want to know that there was something related to this that went wrong. You don't want them to wake up and, the text box wasn't doing the right thing, or the validation was incorrect. That's not something that I would like to get woken up at 1 o'clock in the morning for. But if there's a Twitter-like meltdown that was happening, definitely that makes sense that we should be able to track all those things using a tool like this, that there's something really terrible happening in the application in production, and there's a data that I can use. And of course, you can drill down and see all the things that are happening for your request, where your errors are, things like that, and find out how you can fix this. So what this is giving you is data-driven approach to make changes to your application, instead of, oh, I feel like this. This is what is happening in production. I think that's what's happening. No, there's no thinking. There's no feel like this or whatever. There's no wishy-washy stuff. The data is in front of you that you can make use of to really prioritize things, improve your application, and basically it's feeding into your business. Once you make your application robust, if you're an e-commerce website or whatever you're trying to sell on your site, it's going to help you a lot from these kind of tooling in place. And they're really critical from a DevOps standpoint.
So another important, small, but possible behavior to start thinking about is in your process to start thinking about things in smaller pieces and by their business function in slices. We really like to talk about slices instead of layers with apps. So for example's sake, if we take a simple change like adding a customer's address to a form and to the data behind it, you're going to be touching all the tiers in your app from the UI to the application, and then your domain entities in your database. And regardless of how your app is architected right now, you can start thinking about the boundaries of that change. And when you're implementing it, looking at, okay, I want this business function to stay isolated only in these parts. So I might change all of these pieces of the app and they might still be coupled in that way, but how can I make sure that this customer address only lives in this little slice? Keeping that organized and isolated, and also as a body of work, small, and obviously adding a customer address is very, very tiny. But if you start thinking about keeping things small with the problems that might be a little bigger than that, it can really empower you to focus on things, to trace down where the errors are coming from. There's less weirdness when things are isolated. and ultimately can help, just that thinking about that can help lead you towards some of these other practices.
Right, and this is not a, probably this is a contrived example, but everybody's familiar with adding customer address, so that's why we took it. But then in your real world situation, to carve out a thing like this could be really tricky. And it involves product owners, business users, developers, operations, whatever it could be, that you're building these things together. You're trying to figure out what can be the smallest thing that you can deploy that's going to be reasonable, usable in production. And to figure out that means you're talking to everyone. That means you're kind of asking everybody to think this way. That means you're affecting the culture when you're trying to think, okay, this is my small sliver that I want to deploy to production. Then how can we build our big thing that we want to do? How do we, let's say we want to build a SpaceX rocket. How do we build it in a chunks like, okay, adding a customer address like at the small level like that, and then push that change into production. We're asking everybody to change their thinking. We're kind of leading that change.
And that having all those folks involved really does help build that shared ownership, that feeling of we need to do this together, and you'll fall into having the culture.
Absolutely. And what helps in this as well, like when you have the building robust pipeline and automated things, right? Like, so if I don't have to think about how my code's going to be pushed to XYZ environment, it's just repeatable process. I can do the same thing on my machine, and same thing happens on, like, let's say QA machine or the developer environment or production, whatever. Similar things happen. It's just where the database is or where my container is and things like that are different. The addresses are different. The process is still the same. The chances of me creating the situations that are happening in production, reproducing those issues if they come up, are higher because I'm very close to what's out there. You may not be exactly the same, but you're very close to that. And from that standpoint, you want to have these things repeatable. Infrastructure as code is repeatable. Having build scripts is repeatable. You want to leverage all these things so that you're delivering the value to your customers as quickly as possible.
And with these, you really, you want to start small, right? Infrastructure as code is great, right. But you don't want to just go dive into writing all that code to spin up like, one VM or one app service or one container. You want to think about these pragmatically, add them as they add value to your business.
Absolutely. So with that, we're going to showcase some of these things, and we're really thinking about OSS, because open source software development, because OSS is like I think of it like a leader in innovation. Since I'm an F1 fan and we have F1 in Austin, that's like a experimentation for cars, right? Like, a lot of that technology that kind of gets tried out in that competitive environment over there, and then it comes to our regular cars and all of our lives get improved, things like that. So similar to that in OSS, the community is doing a lot of these improvements, and we would like to take advantage of that and then see what they're doing right. So let's take a look at some of these things. Let me get into this. All right. So I'm taking an example of our open source project, Totem. And what I really did is went to GitHub, and then just clicked on the actions part. And I can set up a new workflow pretty easily over here. What we have is currently I have a CI build, and then I already chose that. And these are my last runs that I had before. I can drill into like exactly what happened, and then what my workflow file looks like. So this workflow file at this point is just YAML, pretty straightforward. I'm saying it runs on Windows, develop branch, and these are the steps that it takes. So in this case, my build step is pretty straightforward. All it's doing is it's just calling build.ps1, which is exactly what I'm going to do on my local machine here. and basically I have a build command which calls the build.ps1 anyway, and that's the script that's going to run, and it's doing the exact thing that's going to happen on the build server as well. So instead of there are plenty of options that you can take, and plenty of actions that are available on GitHub Actions that you can go and you can do all kinds of things and include all these actions in there. So you can have deployments. You could deploy to Azure. You could deploy to AWS. You can deploy to GCP. There are plenty of actions that are out there that you can take advantage of, and then and build your workflows that way. So for us, it was pretty straightforward. This project is pretty straightforward. All we're doing is that we're trying to build this project and then running some tests at this point. The deployment will probably deploy this somewhere on the cloud for our test purposes, but all it's doing is running certain, building the application. It's a ASP.NET Core application. It built it. It's running the roundhouse scripts, and then just setting up my local database, and then it's going to call some tests, the unit tests, and then some integration tests, and it also has some JavaScript tests. So all of these things are running on my machine, and that's exactly what's going to happen on the build server, which we can see here was the exact same run that happened. So what's really, this goes back to that repeatability of things, where we can repeat what's happening on our integration server on my machine as well, so that if there's some problem here, the chances of me recreating that are higher.
And you can even, if you're thinking about it as you're coding, if you run the build script, you're going to catch the errors before your teammates see it and give you a hard time.
Absolutely, and that's what the distributed environment of Git as well is there. Like if you're working on a feature and then you have merge conflicts, you see them, and you won't be able to push anything until you fix those. Instead of like everything getting polluted, you're making sure that you're pushing the work. That's quality, that makes sense. That's not going to break everybody else on your machine first, and then once it works. And since we are kind of driving towards creating our environment, that's very similar to what we do in production. You may have containers, you may have infrastructure as code, whatever it is, it makes sense for your application. You want to do that. So from the build standpoint, the build script standpoint, we use this task-based system called Saki, and this is what my build does. The CI stuff, I can do a whole bunch of things. I can run examples, whatever it is. And these tasks are pretty straightforward. It's just calling some of the .NET tasks underneath, and then running some tools, and it's calling JavaScript tests. All of these things are pretty straightforward to set up. So that's for the web application. So if you look at Jimmy's library here, which is pretty straightforward as well, you can run that build very easily. He's doing something similar. All he's doing is in the YAML file, is just calling that build ps1, which we're going to run locally. I thought I was running it earlier, which is pretty straightforward. It's a small library. We had the web application before, and this is a library. So since this is an open source project, what he does, he pushes it to MyGit. And then what's really happening here is that once the build passes, he's pushing that to his particular MyGit instance here, and then that's his API key, which is going to be in the secrets that we'll look at in a second. And that's what his CI build is doing. Let's look at one other action that he has. So this is his release build, which goes to NuGet. So in this case, there's an extra step here. So afterwards, everything is great. He's going to push that library to NuGet. So these are the kind of things you can do very easily, and it doesn't take a whole lot to start setting this up. You can just go to GitHub Actions, say new workflow, and start building. GitHub has already recognized this is a C#.NET Core project, so I can start setting up right here. But in our case, we already had build scripts, so we just plugged those in and started moving forward.
And if you don't have a build script, I mean, that's what's so nice about GitHub Actions is it has all these templates. You can use the YAML, right? If you don't know PowerShell too well, you're fine just running the .NET CLI to build your app. You can get going on this without doing a lot of extra upfront work. If you've got a build script, great. If you don't, still set this up and have it build your code for you in a repeatable and automated way.
Right. And here I want to quickly touch upon, it runs on Ubuntu latest, that his build is running on Ubuntu latest. So there are multiple environments like that that are supported by GitHub. You can choose your flavor. You can build on Windows latest, which is what our Totem build does. Jimmy's build is running on Ubuntu latest. You can even build on Mac if you have an application that is very specific to Mac, that needs Mac. Your mobile applications probably would need Mac. So at that point, you can run those kind of builds over there. And then we also looked at the secrets. You want to check in your API keys and things like that directly. GitHub provides a very nice way of managing your secrets. And then you can just plug those in, and then they're obfuscated nicely so that even in your logs and everything, the console logs that you saw when your build runs, they're not going to show up as like, oh, this is your API key that I'm going to plug in here. So all that thing is taken care of for you. And they give you example if you're using Bash, what to do and things like that.
And that, if you're running open source and somebody forks your app, right, you want them to be able to run your build, but you don't want them to be able to push up to your NuGet package till they've merged what they're looking for. So it's good to have those separatable.
Right. And from the build script standpoint, most of us use Saki. And what it does is just gives you like a task-based build process system for PowerShell. That's just avoiding some of the boilerplate that you may have, and then you can take advantage of that very quickly. If you had something like TeamCity in place, like no big deal, you could do the same thing with TeamCity as well. You can build Jenkins pipelines, and so just because you used to have Jenkins, and now GitHub Actions are really cool, and there's a lot of stuff that's out there. There's about 4,000 different actions that you can pick from. Doesn't mean you drop what is already working for you. Just stick with that and just make little changes. So if you have Jenkins and that's working, that's fine. And the next example we're going to see is Kantasa University. This is another thing that we Jimmy forked from Microsoft Kantasa University application. And this is really our way of building .NET Core, ASP.NET Core applications. So that's what we have, and then we put that on Azure DevOps. Right, it's just a sample app. And here we're putting that on Azure DevOps. So what we're trying to do is exactly the same thing that we saw in GitHub Actions, but this time it's happening in Azure DevOps, which is not too different from what that thing does, what GitHub Action does. In this case, we have pipelines, and then you can set up what that's going to look like. You can start seeing similar things like, oh, what my VM image should be for this build. Windows 2019, things like that, all the other settings. I'm just creating a YAML file. Even though, yeah, there are a lot of things happening in here, it's still calling PowerShell, whatever it could be. You can do the same thing on multiple different things, multiple different cloud options, and then start going from there. So all of these things are giving you a lot of head start if you're trying to build these applications and push them to production or whatever environment that you may have. You can do the exact same thing using AWS Cloud Build, and they support YAML as well. Runs as in this case instead of runs on or VM image or whatever.
VM image, yeah.
Right.
They're all
these
so
variables,
similar.
Right. The idea is the same. The principles are still same. Just the name, the implementation could be slightly different that you may have to get used to if you're moving from cloud. And that's where the build script side of things comes in handy. That, hey, all I need to figure out is how do I call PowerShell script from YAML instead of building all the other different things. If you think that you're going to be moving and switching clouds, things of that nature, you can deploy these things very easily. And like I said before, Amazon also has this pipeline feature where you can build these pipelines very easily. What we have in Azure DevOps or GitHub Actions.
And that, since they're also similar, if you're already in one of these ecosystems like Yogi was mentioning, don't ditch what you've got. Just, the only wrong choice is to not use it at all.
Right. So with that, let's tie everything together.
So we talked about how DevOps are such a critical part to how we run our business, and that they're behind the scenes, but they just create success and allow you to have great successes and deliver value for your business. We talked about how it's not a department or a role, it's a mindset. It's really a culture that everybody's sharing ownership on taking part in DevOps and achieving these things. We talked about how you can build up to those big cultural changes if you make small incremental steps towards it. And then also about being pragmatic about those decisions that you're making. How do you get to this without blocking yourself? Just think about what value you're getting out of each of these tools or practices as you add it. And finally, that cloud accelerates progress. Just like Mark Ruffalo in movies, being on the cloud just makes everything a little bit better.
Right, and not being a blocker is a big thing, because let's say you may not have, you may not be on Azure DevOps, or you may not be on AWS, or you may not be able to get on GitHub Actions right away. You're using Jenkins right now. That's fine. That's completely fine to make use of that, and then make little progress at a time. You can still start with deploying that into, let's say, containers, your application. And then that you can move one day to cloud. So getting ready to move to cloud is also a very small step that you can take, and then that will affect the whole thing going forward and making your applications better. And that's what DevOps is all about: these small things that you can do in your life cycle, your software, to improve everybody's lives. So again, we are trying to build this repeatable, robust pipeline to deliver the value to our customer using DevOps, and you can do this very easily in cloud. And again, respond to issues we saw as well, like how we can do that using measuring tools, things like that, to understand what we can do to deliver value to our customers as quickly as possible. However, it doesn't mean DevOps is going to be solving all the problems in the world. It's not going to address world hunger or anything like that. It doesn't mean you're going to be able to deploy twice as fast as you did before. It's definitely going to improve than what you had before if you're slower in deploying the application. But we want to be realistic and say that if you have a problem in your application that are significantly large, let's say you're doing search in SQL, for example. So at that point, DevOps is not going to fix that in this way. You may want to really think about the technology choices that you have. You may want to think about moving to something like Elasticsearch at that point. So those are architecture decisions that we saw are also part of DevOps. But then, it's not going to just having a small, robust pipelines are going to help you from that standpoint. So if you're doing something, it doesn't mean that you don't have any work to do. You still have work to do. It's just helping you, making it more efficiently.
Yeah, there's naturally no catch-all solutions in software. There's no nutritional value to YAML, so definitely not going to be solving hunger. But the DevOps, and especially with the holistic approach like this, is just going to allow you to focus on the important parts of your development, on accurately delivering business value, on making sure your code is up and your customers and your clients are getting, your users are getting what they need from your apps. And just deal with the bigger picture, because these other pieces are automated and measured and just running without you.
All right. So with that, we'll do some question and answer. We have a couple of questions here. All right. So first question is, what's the price of GitHub Actions? So the quick answer to that is nothing. You don't have to pay anything to get started on GitHub Actions. Very straightforward. Like, you come to your repository, click on Actions, and start building your workflows. So what you can get, you'll get access to plenty of these actions, which are, let's say, deployment. I don't want to. So there's about 4,300 actions that are out there that you can take advantage for free. But if you come down here, and let's say I want to see what the paid actions are. So you may have reasons to use this 59 actions, and then you may have to pay for those. Or if you're on Azure, You have to pay Azure, but not for Actions. So things like that, that could be that you may have to pay for, but to have Actions and have a workflow, you don't have to pay for that at all.
And some of these might be services that you're using and paying for already, and it's the part of integrating with it might be in that cost, but.
Right. So outside of these 59 actions, you don't have to pay for anything at all. What's the next? Let's see the next question. All right. So we looked at this slide where we said the culture gets affected by your little actions that you're taking. The question is, how can GitHub affect my culture? So, okay, for that, I like to go to one of my favorite projects that I've used for identity server. Let's go to their GitHub. So when I was using, and this is again goes back to the OSS nature of things and how they're kind of like on leading front of all these movements that are happening. So when I was using identity server, at that point, I had a problem that I was looking at, and then I thought there was a bug in identity server. So I went in here and I started, okay, I want to create an issue. So click on new issue. Said, okay, this is a bug report. But look what happens when I click on bug report. They give me a template of what I need to do. What I need to do myself. Let me zoom in a little bit. What I need to do before I file this bug report. And there are steps in here and I need to put them in there. Like, okay, these are the steps that I need to do to reproduce this problem. If you have logs, things like that, they help me out here saying, okay, these are the things that you need to do before you even talk to us. So that what's really happening here is that they're making me take a step back and rethink about my problem. And in this case, what happened is it acted like a rubber ducky. And in order for me to try to explain it to them what the problem was, I solved my own problem. Because I was able to find, okay, this is a little thing that I overlooked. And because of that, I thought there was something wrong in identity server. Instead, it was my error, my issue. And then I just fixed my code and then moved forward with that. So it's really what they're doing is that they are helping asynchronizing your workflows. So I didn't need to call the maintainers, the people who maintain this application saying, hey, there's something wrong. Can you help me with this? No. They helped me without even talking to me, without interacting with me at all, without sending an email to me, nothing, by creating a template like this, just such a small thing that you can do. And then that helped me solve my own problem. And that's how you can promote that asynchronous culture with these tools. And when you go in here, there are plenty of different things, plenty of different templates that they have, feature requests, things like that. That they give you sample templates on like what you need to do in order to request this, so that they're teaching me how to deal with them, and that's a great thing that you can do to improve your culture.
And that's, I mean, just part of the nature of open sourcing is that you've outsourced some of your bug tracking, and you're thinking about inventive use cases for your library or your app. And like we're, as developers, we're curious. We like figuring things out. So if your code's out there, maybe you want to figure out what's going on, and if they can lead you to that, that's great. But even just digging into the code instead of blindly sending an email or a support ticket saying, hey, this is broken, being able to see what's in there really transforms how people interact with your service or your application.
Right, and they don't have to, when they're maintaining, this is a pretty successful project. So they have 6,000 plus stars, there are not many forks, things like that. So they don't have to actively support anyone saying, oh, like Yogi has a problem, let me respond to him like 1 o'clock in the morning. They don't have to do all those things. They're teaching me how to deal with them. Because if they respond to me at that some ridiculous hour, so I'll expect that kind of stuff going forward. So that will be teaching me wrong things. So they're here with these templates, they're teaching me the right things how to deal with them, and how to set the expectation and things like that. So this is a really cool way of affecting your culture. This is a very small thing. There are about 5 lines here that they put in here, but they're so helpful, and that's going to affect your culture, making it more asynchronous in this world, like with the off pandemic and things like that, because we are getting pushed more and more working asynchronously and things like that. All right, so we are on time, and you can contact us at headspring.com. You can send us email. You can tweet at us. Go to Headspring Labs on GitHub. Check out our projects, fork us, things like that. Everything's great. And with that, we don't have any other questions, and we will talk to you later. Thanks, Patrick. Thanks, everyone, for joining.
Thanks. Yeah, thanks, crowd.